So this is the second video for systems of equations, and we're going to look at the graphing method. And so your job, or the I can statement, is to be able to solve two equation systems by graphing both and determining where they intersect. And so that's what we're going to do. So we're given both of these equations here, and the first step in trying to find a solution using the graphing method is to solve both equations for y so that in step 2 you can graph them. It's difficult to graph things if they're not solved for y, so that's where we want to start. So I'm going to do my first step of moving my negative 4x to the other side, or adding 4x to both sides. And then I'm going to divide everything by negative 2 to isolate y. Okay? And I'm going to do the same thing over here in blue. So I'm solving both equations for y right now. So 8y equals a negative 4x minus 24. Got to divide everything by 8. So y equals a negative 1/2 x minus 3. Okay, quick note about how I solved for y. Maybe you already got this down, but I know it's probably in the beginning of your algebra career here. So, for example, the first step here, when I moved the 4x over to the other side of the equation, mathematically what I did was we subtracted 4x from both sides. So I'll just write it like this, I guess. And so that's how these canceled out on this side, and you ended up with a negative 4x on the other, because we subtracted them from both sides. But here's a little trick that that a lot of algebra students use to make their lives easier, is if you have to move something to the other side of the equation, you just change the sign of it. And I don't know if you've noticed that pattern, but that's a recurring pattern in algebra. If you got to subtract something from both sides or add something to both sides, really the net change is this same item on the other side of the equation with a different sign. And so the way I think about it is just moving it across the equal sign and changing the sign. Mathematically, I know I'm subtracting it from both sides, but the way I think of it to make things go faster for me is just a movement. Anyways, I don't know if that made sense or not, but hopefully it was helpful. Okay, let's come back here. Let's start by graphing the red line. Red line is y equals negative 2x plus 6. So y equals negative 2x plus 6. I know my y-intercept is at 0, 6 because my b is 6 here. And I know my slope is negative 2, or negative 2 over 1. The reason I wrote it as a fraction is I'm going to take a shortcut here in graphing them and use the rise over run slope to help me do it. Instead of creating a table of points, which I very well could, I'm going to just use the slope and the y-intercept to graph it. So every time I go over 1, I go down 2 because of the slope. So let's see, over 1 up 2 as well. You can think about it like that. And so I have this nice line here. And so I'm going to connect it here with a computer-generated line, because I'm really bad at drawing lines on my slate here. You probably noticed that in the last video. Okay, and that's slightly off, so let me try that one more time. I will get this. Just a matter of practice, I think. Okay, that's a little better, and I'm going to live with that. Okay, slightly off, but it's better than the last try. So the next equation is y equals negative 2x minus 3. So y equals negative 2x. Oh, I'm sorry, I said that wrong. Y equals negative 1/2 x minus 3. So let me rewrite that. Okay, cool. So let's graph that real quick. And again, my y-intercept is negative 3 here. And my slope is a negative 1/2. Okay, so that means that my rise is a negative 1 and my run is 2. So every time I go over 2, I'm going to go down 1. Over 2, down 1. Over 2, down 1. Over 2, down 1. And so on and so forth. And as you can probably see, I kind of did this on purpose, because I want you to develop a sense of what you need to do to find a solution. As you can see, I didn't carry my red line out far enough to really see where they intersected. So I wasn't quite sure where the blue line was going to end up. So let me select this red line again here and delete that and give it a third try. And I want to carry it all the way down so it intersects the blue line this time. See if I can get this just right here. Okay, that's about right. Okay, great. So it appears as though right off the bat when we're looking at this, they intersect here at the point 6, -6. Now this is one of the weaknesses of a graphing method, is everything has to be done just right, neatly, to tell exactly where they intersect. And as you can see, I have, even on the computer, I had a hard time getting my line to line up perfectly on my points. It's much easier on a piece of graph paper with a ruler and a pencil. But it's still a weakness. Especially if you don't end up with an intersection on a solid point of whole numbers. You know, if this was 1.5, it'd be difficult to see if they intersected in between x is 1 and x is 2. So this only really works well for systems that have a solution that includes whole numbers in the x and the y values. So there are definite limitations. But at the end of the day, a solution to a two-equation system of linear equations is where the two lines intersect. But I'm not done yet, because I really should test this. I have to make sure that the point 6, -6 works for both equations. So that's what I really should do before I move on. So I'm going to erase all this stuff that I did to solve for y, in case I made a mistake in solving for y. And I'm just going to plug these values in. So my x is +6 and my y is -6. So I'm going to plug those in and see if this equation works, or I'm sorry, see if this point works for both equations. Let me do the plugging in here. Always check your work, right? Especially in algebra. There's really nothing in algebra that can't be checked, which is kind of nice. So let's simplify both here. This is -24 minus a -12 equals -12. We can see right off the bat here that that works, because this is -24 plus 12 equals -12. And finally, -12 equals -12. So this worked. Put a star by it. This point here worked for this equation. It got us to a true statement. So I'm going to check this one now. 24 plus a -48 equals -24. And similarly, this becomes obvious to us. A -24 equals a -24 when you simplify this left side of the equation. And so the point worked for both equations. And because the point that that we identified here on the graph works for both equations, I can be extremely confident that this is indeed a solution. This right up here is a good solution for both of these equations. Because they're linear and they're straight lines, this is also going to be the only solution, because this is the only point at which the two lines will intersect ever. Just a quick side note, if you have two parallel lines, there will be no solution because they'll never intersect. And as another side note, if one of the equations isn't linear and it's a curve, you may have multiple points of intersection and multiple solutions. So anyways, I hope this example was helpful for you. If you need any help with anything, please fill out at the front of the website, there's that contact me form. Just put in your question there or request another example and I'll gladly provide it. Good luck to you guys.